Welcome to day 5 of pre-algebra prep class, and today we are going to talk about clearing the fraction and clearing the decimal. When we think about clearing something out, we think about getting rid of it, right? Maybe your mom's gotten rid of your old clothes or old toys or something like that. They've come through and they've cleared out the toy room or they've cleared out your bedroom. And sometimes we like that and sometimes we don't. But when it comes to math and comes to fractions and decimals, most people have a little bit of a adverse reaction to having to deal with lots of fractions or dealing with lots of decimals. So here's just another option. It's good to be able to do both. It's good to be able to work with fractions. It's good to be able to work with decimals. But there is another option that sometimes we can actually get rid of those fractions, get rid of those decimals, and just deal with whole numbers. And so that's what we're going to talk about today. And today we're going to start, first of all, with clearing the fraction. But I want to do that, first of all, by giving an example of what it would be like just to work with the fraction. In some cases, it's just as easy to deal with the fractions. If I see this equation right here, it has x is equal to, x minus 2/7 is equal to negative 128. Well, just like any good one-step equation, this is a subtraction question, so I'm going to solve it by adding, and I'm going to adding its opposite. And I'm going to add its opposite over here. So negative 2/7 plus 2/7 just simply cancels each other out, and I'm left with x over here. But over here, I have to do a little bit of work because I need to find a common denominator. And in this case, our common denominator would be 28. So I can say negative 128. I'll leave that the way it is. This one down here, in order to get 7 to be 28, I'm going to multiply by 4. And that means I multiply the top by 4. So I have a negative 128 and a positive 28. So I don't know why I wrote 24. There we go. And a positive 8 28. And so I end up with 7 over 28. And if I know anything about my fractions, 7 over 28 can be simplified, and I'm going to go in the opposite direction, normal, and I'm going to go back here, equals 1 over 4, or 1/4. Well, there's another way we can handle a question like that, especially if they get much larger, and that is we take our same equation, and this time we still want to use that common denominator. What we're going to do is we're going to clear the fraction out of the problem by multiplying it by that common denominator. In this case, that common denominator is 28. And would you all agree that 28 is the same as 28 over 1, right? If that helps us, for some people it does. And what that means is that we're going to multiply or distribute that common denominator multiplied times every single term in our question. So if I take 28 times x, hopefully you would agree that that just becomes 28x. If I take 28 times negative 2/7, I can either multiply 28 times 2 and get 56, divide that by 7 and get 8, or I can do a little cross-canceling and know that 28 and 7 share a factor of 7. It goes in there 1 time, goes in here 4 times. 4 times 2 is 8. Look what happens over on the other side over here. Can those cross-cancel? Is that nice? So I'm just left with negative 1 times 1 over 1 times 1, which just gives me negative 1. Correct? So then, what happens if I now have just a two-step equations? I'm going to add 8. I end up with 28x minus, or I should say equal to now, 7. And out of that 28, I'm going to divide both sides by 28. And I'm left with x over here equals 7 over 28, which we already previously discovered is the same as 1/4. So both ways will give us the same answer. We just need to determine which way works best for us. How I would say personally, if it's just a couple of fractions, I probably just deal with them the way they are. But if I have a whole set of them, sometimes clearing the fraction could be a helpful thing to do. So let's try that again, maybe in a situation where it might be a little bit more helpful. And again, at any time, if you lose me in what I'm describing or I'm talking too fast, just slow it down, pause it, catch it back up, rewind it, anything you need to do to make sure that goes a little bit smoother for you. So let's take this equation here. What happens if I have 2 over 3 plus 2x plus 7x is equal to negative 71 over 15. Well, right off the bat, I know that I'm not the one that's going to really be excited about trying to work with a negative 71 over 15. So what I might do is, in this case, I might find a common denominator. And this might be a 15. So because I know both 3 and 15 can go evenly into 15. So I'm going to multiply everything through by 15. And when I say everything, that means every single term. Can I cross cancel 15 and 3? Sure. 3 goes into both. It goes in there 1 time and here 5 times. 5 times 2 is 10. Plus 15 times 2 is 30x. Plus 15 times 7 is 105x is equal to, now look what I have over here. Those cross cancel. I'm left with negative 71. Pause a second, kind of soak that in. What some people do in this case too is go ahead and add those two together, and then they only have to distribute to the 9x instead of both of them. Either way is fine. Now I end up with 10 plus 140x is equal to negative 71. Subtract 10, subtract 10. I end up with 140x. Oopsie, forgot my x in there. Is equal to negative 81. Okay. And then I'm going to combine the two. Oops, I'm sorry. I goofed up. I thought I was a little bit off. Somebody's got to catch me on that. So I had 35x. How about that? 135x. That's better. And divide by 135. Divide by 135. And I have x is equal to, now it's a negative. And if I add 8 and 1, I get 9. So I know that 9 can go into that. If I add 1, 3, and 5, I also get 9. So I know that 9 can go in here as well. I know that 9 goes into 81 9 times. I know that 9 goes into 135 15 times. Guess what? Something can still go into both of these. I'm going to bring that up because I know I'm losing it on my screen there a little bit. So 3 goes into 9 and 3 goes into 15. So my actual answer is a negative 3 over 5. Hopefully we can see that right there at the end. But there I come, and if you notice, even though I cleared the fractions, it's still quite probable that I will end up with an answer that is a fraction, which is perfectly fine. Okay? So that's what we're doing. When we clear the fraction, we find a common denominator. We multiply every term by that common denominator. And when we're done with that, we should end up with a whole row without any fractions. Now, the same idea can be had when we deal with decimals. I can also clear the decimal, and in many cases, it's a lot easier job. So since we've already done that, let's jump onto the decimal, and let me give you one that looks like this. I have 1 minus 1 and 5/10 x equal to 4/100 minus 3/10 x. So hopefully you can read all of that pretty well. Now, again, I can work with the decimals. Not a problem. We can do that. But if I don't want to work with decimals for some reason, I can get rid of them all simply by finding all my decimal spots and notice which number goes further down in place value on my decimal chart. This one goes to the tenths column, tenths with a TH at the end. This one goes to the hundredths column, that's hundredths with a TH at the end. And this one also goes to the tenths. So the one that goes furthest down is our hundredths place, which means I can come back and I can multiply every term by 100. Which, if you understand decimals, multiplying something by 100 actually technically moves the decimal 2 spots. An easy way to remember that is it has 2 zeros. If I was going to multiply it by 1,000, it has 3 zeros, and I would move it by 3 different spots. Sorry about that. So I could, if I had it by 1,000, I could move it 3 spots. If I had it by 10,000, move it 4 spots. How many zeros there are kind of determines how many spots we move our decimal. Another way to think of it. But I can multiply this through, so 100 times 1 is the same as 100, minus, again, if I move my decimal 2 spots, move it 1 here, then I move it another spot, would you agree that that makes this 150x? Excellent. Now here's where it's really helpful. Move it 1, 2 spots. 100 times 4 hundredths actually just gives me the number 4. Then if I multiply the last one times 2 spots, I end up with 30x. So now look what I've done. All my decimals are gone. A good reminder and a good warning is I must multiply every single term by that 100. If I don't, if I skip one for some reason, my answer will be completely wrong. So make sure you stay focused on what you're doing when you do that. I'm going to go ahead and add 150x to both sides. That gives me 100s left over here. 4 plus 120x. All right. I'm going to now subtract 4. I end up with 96 is equal to 120x. Hopefully you're still with me. Now, if I know a little bit about my math facts, I can start to sense something here. Because I know there's a number that goes into both 96 and 120 pretty well. And so I'm going to shoot this over here. I end up with x is equal to 96 over 120. Both of those can be divided by 12. So now I end up with x is equal to 8 over 10. Now I can either simplify that into a fraction, but didn't they give us our problem in a decimal form? Generally, if you work with your teachers, generally, if you get a problem in decimal form, they want an answer in decimal form. If you get a problem in fraction form, they want an answer in fraction form, unless it comes out to a whole number, of course. So if I read that, that is read 8/10. So if I know anything about my decimals, I know that 8/10 is also written as a decimal, just like that. So there is my answer. So 1 minus 1.5 times 8/10 is equal to 4 hundredths minus 3/10 times 8/10. All right, hopefully that's helpful to you. Slow it down, go through it again and again. A couple things. If I had everything here and all I had was 1/10 was my lowest, I would multiply everything through by 10. If I had a decimal in the thousands place, I would multiply everything through by 1,000. Wherever my lowest place is where I multiply everything through, and then I go from there and solve it just like a normal two-step, multi-step equation. Hopefully that's helpful. I hope you have a great day, and I will talk with you soon.